Okay, so for our law of conservation of mass, basically what we're looking at here is that matter is neither created nor destroyed. So in other words, the matter that you start with is before a chemical reaction has to be there after the chemical reaction. The new substances that are made are really just made out of the old ingredients, right? So that's why we use balancing chemical equations to make sure that we are following that law of conservation of mass. Okay, so to answer this question, what does the law of conservation of mass say? Matter is neither created or destroyed. So not created or destroyed. So in other words, amount of atoms in reactants has to equal the amount in products. Okay? All right. What is a balanced chemical equation? That is when you have the same number of atoms in reactants and products. So we like to ask you guys questions that are going to be saying like same number of subscripts or same number of coefficients, and that's not true. It's same number of atoms. So that one, the page that would help you with that a little bit is going back to how we used to figure out how many atoms are in a chemical formula that has a coefficient, right? So coefficients take care of everybody behind them, and subscripts take care of whoever's directly in front, and then subscripts outside of a parentheses goes to everybody on the inside. Okay, so just so you can kind of review that one. All right, what information can you determine from a chemical equation? You can determine elements, compounds, mole ratio, which remember is your coefficients. So that's your coefficients. States of matter, and then specifically whoever is reactants and who is a product. Okay. What do you use to balance chemical equations? And that answer is the coefficients. So we have our list of vocab words again on that one page that has your counting atoms. So make sure you take a look at those. In a chemical reaction, the total mass of reactants must be equal to total mass of products. Okay, we'll do an example of that one down here. What does aqueous mean? It means in solution or homogeneous mixture with water. Dissolved in water is another way to describe that. Remember, everything that is seen in your chemistry class usually that you guys define as or call chemicals, those are all aqueous. We don't put liquid very often. Liquid is reserved only for water. And then melted substances. All right, so according to the law of conservation of mass, the number of atoms on the reactant side must be equal to the product side. And then our mass before has to be equal to the mass after, which is how we can answer this additional question, which is if 20 grams of H2 and 35 grams of O2 combine, how much H2O is produced? So basically what this is describing is we have 20 grams H2, 35 of O2, and I'm asking you how much H2O in grams. So remember what this is whatever we start with, we have to end with. So we would add these two together, to make that total. So 20 plus 35 would tell me 55 grams of H2O. Remember, we're not applying anything with our coefficients. Okay? So that is through number 12 so far. I'm going to keep going. So what are the 4 signs of a chemical reaction? So 4 signs of your chemical reaction were found in the notes that have the 2 graphs for endo and exothermic. Okay, so we wrote down those 4 signs of a chemical change. So we have change in energy, so meaning temperature increasing, or if you have light. Bubbles, production of a gas. Precipitate, which is a solid that settles out, and then color change. So for that, I will go ahead and put color change. Gas. So remember, bubbles goes with that. A precipitate. Or energy change. And remember, energy change can be light or temperature going up or down. Okay? Finally, precipitate is a solid formed from 2 aqueous solutions. And specifically, it's something that forms from 2 ionic substances. Okay? All right. Activity series. So elements can only replace elements that are listed below it. So in a single replacement reaction, we have to refer to our activity series. So we got to see that on our notes page that has our different types of reactions. So if you look down here with single displacement, you have an activity series here for our metals as well as our nonmetals. So the example that they gave you was straight from your lab that you guys got to see. So zinc and copper. So between those two. So if zinc's up here and copper is way down here, zinc can replace copper, but copper cannot replace zinc. So yes and no. Okay. All right, next one, we have predict the products for the decomposition reaction. So decomposition is your breakup, so it means things splitting apart. So we can go ahead and break this apart. We have Na, and then you, instead of just writing Cl, that's part of our diatomic 7, so we do have to include that little 2. Over here, we're going to split it into Li. Remember, subscripts do not come across. Okay, that's what balancing is for. And then we have our oxygen, who is part of our diatomic 7, so the 2 comes across. If you were to turn around and balance this, you would say 1 Na, 1 Na, 1 Cl, 2 Cl. So I'm going to go ahead and put a 2 in front of this. Okay, and so now our Cl's are balanced, but we have to fix up our Na. So that means 1, 2, we got to put a 2 in front of that. And now we have a 2, 2, 1 mole ratio. For the lithium oxide decomposition, we would have very similar. We see that we have 2 oxygens here and only 1 here, so I can go ahead and put a 2 in front of that. So now my oxygens are balanced, but my lithiums, we have to fix that up with a 4 in front of the lithium. And now that's parts balanced. Okay, I'll do number 17 on the next. No, I'll go ahead and run through that. Okay, so with our counting up how many atoms, remember you go in to out. So go inside, outside. Okay, so for example, we're going to start here. So calcium, we have a 1 that's next to it. We don't have any parentheses. And then we have a 3 in the front. So we have 1 times 3, which will be 3. Okay, so again, we're going to do a personal, parentheses, and then a coefficient last. Okay, so that's how much calcium. For carbon, we have a 1, We don't have any parentheses again, but we have the 3 in the front. So 3 carbons. For oxygen, I have a 3. I don't have any parentheses, but we have a 3 in the front. So we have 9 oxygens in this example. Down here, we have, for magnesium, I have a 3. I'll go ahead and write it below. A 3, no parentheses, but a 2 in the front. So we have 6 magnesium. For my phosphorus, I have a 1. I do have parentheses, so I'm going to go ahead and say times 2, and then I have the coefficient in the front, 2. So 1 times 2 times 2 would be 4. For oxygen, I have a little 4. I have a 2 outside the parentheses, and then I have a 2 in the front. So 4 times 2 is 8, times 2 is 16. And then finally, for this last one, I have a 1 for nitrogen. I have a 3 outside the parentheses, and then I have a 4 in the front. So far I have 12, but we can't forget that we also have 1 more nitrogen there. So we technically have plus a 1 times 4, so 4 more. So we have 16 total. Kind of a tricky one there. All right, then your last one should be easier. We have a 4 times a 3 times a 4. So 4 times 3 is 12, times 4 is going to be that's what I thought, 48. All right, so 48 hydrogens. All right, so that's it for the whole front side.